Hello, welcome everybody to my channel PRADIP Sir Classes as PSC where logo can talk the physics. And students, we are in the numerical king series and this is uh, 27. So AC Verma physics chapter 29 question number 49 electric field and potential, and the question number is 49. So students, if you are first, then go back to my playlist. Actually, there are 30 chapter number 30, all the numerical sub chapter number 30, the question chapter number 1 are all completed, and today we are discussing about question number 49. So students, first of all, I say that write down the question and then see the answer. Okay. So question number 49. Question number 49, and a ball of mass 100 gram and having a charge of these 4.9 into 10 to the power. So the information is question number 49. Mass is given, that is 100 gram, and you have to convert first of all this is kg in kg, so this is 0.1 kg, and the charge is also given, so charge equal to 4.9 into 10 to the power of minus 5 coulomb is released from rest, that is u equal to 0 in region of horizontal field is given, so it is uniform horizontal field, and the electric field is, the magnitude of electric field is given 2.0 into 10 to the power 4 Newton by Coulomb. Find the resultant force, what will be the path and where will the ball be at the end. Okay, so students, there is an electric field of intensity, magnitude is also given 2.0 into 10 to the power 4 Newton by Coulomb, and a charge is placed here. So first of all, students, you have to know that weight act in the downward direction, that is mass into mass is given, that is 0.1, and g is 9.8, so this Newton, so this is equal to 0.98 Newton. It is a simple calculation, 0.1 into 9.8, that is 0.98 Newton, and along this direction electric force is act, electrostatic force, and this is QE, so Q into E, and this is force equal to QE. Q means this is given 4.9 into 10 to the power of minus 5 into electric field 2.0 into 10 to the power of 4. So again it is 9 to the 8 and 9, this is 0.98 Newton. So these and these force is equal. Okay, so there is an electric field along this direction and a charge is kept at rest, and along this direction there is an electric field, and along the downward direction there is a weight act. So the resultant is along 45 degree. So the resultant is along 45 degree. So this is theta. If this is theta, then tan theta equal to this one by this one. So 0.98 by 0.98, and this is equal to 1. So theta equal to tan 45 degree. So 45 degree is the direction and the path of the particle is along this direction. Okay, so first number question is, what is the resultant force and the magnitude of the resultant force, that is F r equal to root over of 0.98 whole square plus 0.98 whole square, and it is act along 45 degrees. So this is, if we take and these square, so 2 into this square, so when 0.98 and this is root 2 this Newton, and it is approximate root to 1.4, 1.38. There is approximate 1.4 Newton force act along this direction with a 45 degree of angle. Okay, I think students, again I repeat, there is a charge within the field and the electric field act along this direction and weight along this direction, so the resultant is along this direction. Since this is 0.98 and this is also 0.98, so the resultant is along 45 degree along this direction, and the magnitude of the resultant is 1.4 Newton. So the acceleration equal to force by mass, and force is, since this is 1.4 and the mass is 100 by 1000, 100 by 1000, there is 0.1, so this is 14 meter by second square. 14 meter by second square. This is the value of the acceleration with which the particle moves along this direction, accelerated along this direction, obviously. So this is the direction, and for the next part, you have to calculate where it stops and along this direction. After 2 seconds, what is the displacement of the particle along this specific direction? So S equal to ut plus half at square, and the initially it is 0, so half into acceleration is 14 into t square means 2 seconds, so 2 square, and this is 2, so 28 meter. So this is the final answer. Okay, so all the concepts again I repeat. The whole numericals, there is a charge within the electric field which is act along this direction with a specific value, and the weight act along the downward direction, so the resultant is along this direction with 45 degree angle, and the resultant force is 1.4 newtons, so the acceleration is 14 meter per second square, and the charged particle move along this direction, and after 2 seconds it reached 28 meter from the origin, that is from here. Okay, so I think students this is clear for you. Okay, thank you.